Okay, everybody welcome to Codeforces round 695, which is division 2. It's unrated for me, so we'll have a lot of explanations along the way. It will start very soon. Let me show you, like so. And we have a little bit more added to our template, just some pragmas. Sometimes they help optimize solutions a little bit. Not much, but you know, every little thing helps. So let's head into it. Okay, we have n digital panels placed in a straight line. Each panel shows any digits from 0 to 9. Show level 0, okay. Every second digit shown by each panel increases by 1, okay. Okay. Okay, so we pose any panel, and then this pose extends to adjacent panels. What do we want? I don't understand. Okay, number of test cases, we can do this. Or actually, yeah, you know what? Because why not? Right? We also can do it like this, right? Okay. So what do our test cases consist of? Single integer, okay. Okay, so we have n panels, one largest possible number we can get. It appears to me that you just wait until the largest digit is 9 and then pause. And this is equivalent to anything else we can get. Yeah, I think it's correct. I mean, it doesn't matter where you stop. If first digit ends at 9, is it the same as stopping first digit at 9, or is it not? Wait. No, it's not. You don't want to stop first digit at 9. We want prefix to become like 9, 8, 7. Right. Now it's correct. Okay. Okay. The first digit is like so. Then we decrement it and we say like, hey, digit. Well, actually, if digit is 0, then digit becomes 9, else digit decreases, right? I believe we need to output new line here. Let's run it. I don't know. Yeah, so this do not work on Windows. I'm currently on Windows. Okay. But we can add them when we submit. Yeah, let's give it a couple of test cases. I don't know. Seems reasonable. I don't know. We can submit, I believe. Not here, not here. Yeah, okay. What happened? What happened? Okay, okay, very interesting. So we are wrong for some reason, but I don't understand why. Wait, we can stop like so that, I mean, if this digit, oh, okay, because we can stop this and get 989, right? And then it's optimal because it's max prefix, correct? Am I correct? Yeah, I think now it's correct. Okay. Yeah, so the optimal way is to, of course, maximize the prefix, but we maximize by stopping this at 8. But then it will get like 0, 1. Okay. Now the digit is 9, and okay, potentially. Yeah, stupid of me not testing, not syncing. Okay. Very stupid. What are? Don't be as me. Test your solutions. Hills and valleys. We have sequence of n integers. 1, 2. Okay, so index is a hill if it's local maximum. Okay. Valley if it's local minimum. Okay, and strict minimum. Okay. Intimidation value of sequence is sum of number of hills, number of valleys in the sequence. Okay. Can change exactly 1 to anything. Minimum. Okay, so we want to get rid of so we would like to get rid of as many hills and valleys as we can, but okay. Have single. Oh, actually, okay, whatever. So in this problem, we can't change like many different things. If you change one element, it can only affect like 1, 2, 3 potential valleys and hills. So if you change like I, then it only changes like this triple. So this triple, and also this triple. And I believe we can like simply compute these values, so we don't have to like think what is the optimal value to select. So we just or do we need it? Let me think, let me think. In all different values possible for I, if we are very lazy, we have only like 4 elements, we can check 5 values in between, or potentially only these 4 values, right? Yeah, let's do this. I don't want to think a lot, so. So first we compute like current intimidation. Okay, intimidation. Also, we would like to have it like so. Okay. Now we would like to change AI potentially to 4 different values to ruin some of these hills and valleys. Uh, no, let me do it like so. So if I is at least 2, it means that we can change AI. Let me see. No, actually. So for now, I will just put it here. Because I don't want to write this condition all the time, I guess. Okay. So here we check hill valley of AI minus 1, AI plus 1. Here, if this triple so if this is like so and we increase current, oh, this is always true. This is always true. Here we want to check if this. So we'll count like every element affects at most 3 of these, and we will check like what is the current value and whether or not it makes sense to change this value to any of these 4. And it doesn't, like these 4 are boundary values, the only reasonable values to check. That's what we are trying to do here. I don't want to figure out these values explicitly, so I will just try changing AI to all reasonable values, exactly current 4 values around it, to check whether it makes any difference. Okay, so we know the current number. Among these 3, how many are hill values? And what do we want to check? If like so, then it makes sense to okay, let me do it like this. And here like so, and here for yeah, let me clear this out. It gets into the way. With current local intimidation value. Here we try like this, but instead of a current value of AI, we are using a new value that we want to change to. I guess this is like so. Let me create best new local. Best new local is minimum. Okay. Okay, so here we want what exactly? Here we want best intimidation equals min or best intimidation, and here like initial intimidation minus current plus new local plus best new local. Okay. I guess it makes sense. Here we want to see out best. Okay, so in theory, this should be enough. In practice, I don't know. Let's grab ourselves some test cases. Excuse me. Oh, okay, correct. Right. Minimum is undefined because it lies in algorithm. Well, it sounds correct. I'm not sure if it is, but at least it sounds correct. No. I mean, in theory, these four are all reasonable values for AI to change to. But I don't know. Potentially it's not. Okay. This contest is going terribly so far. Well, here we don't want possible. Okay, potentially we were... How did it work in the first place? We were redefining possible later on. What happened? Yeah, we can remain it unchanged because we initialize this initial intimidation. So in my opinion, like the only reasonable values to change AI to are the values of its neighbors. Because like one equality should ruin something. But potentially I'm wrong. But I don't think I'm wrong. Like, no, honestly, I don't understand why it's not working currently. So we have like initial intimidation of the entire array. We check it like so, and it appears to be correct. Like, check that either these two condition halt or these two condition halt. One of them is hill, one of them is valley. Well, I can do like this, but it should not change anything, okay? We compute initial intimidation as a sum of hill values over all possible hill values, right? From 1 to I plus 1 at less than n. And I say like, what is the best new intimidation? Well, initially we can change like nothing. And we look like, whenever we change a number, only its neighborhood changes. So we are concerned with current local intimidation. We computed like this number is at most in 3 hill values. And we check this 3 hill values. So this one, and this one. And also, if like these numbers exist in the array, then it makes sense to change it to these numbers. I think so. Well, and then we like loop through all reasonable values to change to, and try changing. So we count how many values will there be, and update your local intimidation accordingly. To this we update best new local intimidation. Then we update best new intimidation of the entire array. It's initial. We subtract these because these are going to change, and we add this. I'm not sure what went wrong. It seems very reasonable so far. I mean, we can add more values to possible, but I see no reason for that. Honestly, no. And the reason why I think that only these values are reasonable is because like it only matters how these 5 numbers compare each to other, right? And we have 4 of these numbers fixed, and we change the middle one, and it only makes sense like if it's smaller than all of them, smaller than all but one, smaller than all but two, etc. So it should be like 5 values, but I believe that we can check exact boundaries between these things. Because like equality does not create any extra hills and valleys. We want like strictly. Wait. No, sum is the number of hills, number of valleys, not numbers in the valleys. Okay. No, I don't understand. This has to work. Or probably, you know what, like if possible is empty, then best new local intimidation is probably it's incorrect initialization, because we can't always guarantee that local intimidation gets to 0. I think so. Yes, apparently this was incorrect. Well, what I was thinking, people, I don't know. So stupid. So let's check this version. It should be. Yes, okay, whatever. Very stupid of me. I want to minimize and initialize to 0. Stupid. Also. Okay, problem C. We have 3 bags. Each bag contains non-empty multi-set of numbers, or whatever. We can perform a number of operations on these bags. In one operation, we can choose any 2 non-empty bags, okay? Choose number from each of the bags, okay? So take 2 bags and take 1 number out of them, okay? A from first, B from second, remove B from second and replace A with A minus B in the first. Okay. Okay. So we want to like remain only one, leave only 1 number in only 1 bag, okay? Maximum number left in the end. Okay, interesting. Okay, okay. So we have only 3 bags. Well, 3 bags sounds better than n bags. I somehow initially thought that we have like n bags. Okay, whatever. Uh, okay, we read our bags. Now we have to sync, and it's a bit more difficult previously, but it's okay. So we subtract like one from other, and we okay. Let's take a look at the example. We have 1, 2 in the first bag, 6, 3, 4, 5 in the second, and 5 in the third. Want to maximize what remains. So in theory, we want to like subtract minimum, right? Well, actually, think about this way, like what if we like we have max value somewhere here, right? Okay, because we have this problem of we can't subtract numbers in the same bag from each other. Okay. What happens when we subtract like so? All these numbers get this plus. Okay. Okay. Is it okay? Yeah, but what if we subtract like C minus D? Then D will be with minus, plus, and minus. Okay. Interesting. It's actually, do we want like this minus D? Why would we want it? It's going to end with minus. If it's like so, then it's with plus, and this everything this here is with minus. Okay. Yeah, let me think. Like here, the sum of numbers is 3. Here is 5. Here is 18. And I suppose that we can get like this 2 minus this. And the way to do it will be as follows. We take any number here, we pick any number in the bag with minimum sum. We take like a second bag, whatever. We subtract 2 from 5. So here we get 5 minus 2, and we subtract, and we do this for all of numbers in this bag. So here we have like no numbers. Here we have like minus sum of this bag. Okay? And we subtract this way. It will result that here we have the sum of all numbers minus the sum of all numbers here. And then we subtract everything here from there. And it will result in like the smallest bag is with minus, 2 other are with plus. Or actually we start with subtracting all of this from here and then subtract here. What is the second example? Let me think about it. I don't think it's correct. It's like super stupid greedy. What do we have here? We have like 7, 5, 4, 2, 9, 2, 9, 7, 1. So here sum is 8, here sum is 16, here it's 11, And apparently optimal sum is not 16 plus 11 minus 8, right? So we find some smarter way to do it. Let's see what is the smarter way for the second example. Okay, so they don't explain the second example. Very nice. Let's get back to drawing. Okay, so we would like 9 to end with plus, right? We can achieve this by simply like saying, hey, 9 is going to be with plus, okay? 9 will be the last number standard. And then we would like to subtract as little as possible. So let's say 1 gets a minus sign, right? Because of this 1 gets minus, we can then say like, well, this 7 gets plus, right? And we can say like, okay, this 2 gets minus because it gets subtracted from this 7, and this 7 gets plus. Not very nice, not very nice. Or actually, wait, like after we take this minus 1 with minus, we can then achieve that everything else is with plus. And if we take like this with minus, then we achieve like everything in the other bags can be taken with plus, right? No, we can't because we need to subtract something. Okay, so at least one number out of this final bag gets subtracted. Okay. Yeah, so the idea is here like 1 gets subtracted from 9, but only after all of these are subtracted from 1. Because they're subtracted from what's going to be subtracted, and we get like all of them get this plus. This minus 2, it's necessary. I don't know. What is actually the sum of all numbers here? So here we have like 16, 11, and 8. And the total sum is 27 plus 8, 35. And they say that maximum it can be achieved is 29, which is minus 6. It means that we exactly take minus 1 and minus 2. But what for? Maybe the idea is different. Like once we agree that this 1 and 2 are negative, right? We would like to subtract everything from them. So we can like subtract this way, I don't know, probably subtract this way. And then they get subtracted from, like, say, this 7. Okay, so it does not make sense to take more than one number from one set to subtract from it, because you can do, okay, so at most one number from each set gets with minus. Okay. And at least one number from 2 of the set gets subtracted, because we want to get rid of these numbers. Or do we? No, not necessarily. We can get only one, we can get away with one minus if one of the set has one element. Okay. Okay. Can we check like so? Are we guaranteed that the answer is not negative? No, I don't know. Also, we have too many big numbers we can easily overflow. Okay. So if n1 equals 1, then we can subtract, and we can achieve that only a11 gets this minus. Let's say we subtract like everything except one number from a11, and then we subtract this from everything else. Okay. So in this case, in 6040, and we would also like to get several statistics here. I believe it's like so. So we want to use like some of these bags. Are we guaranteed? Yes, we guaranteed that every bag is non-empty. And we'd also like to know what is the minimum element of every bag. Okay. So if n1 is 1, and we can achieve that only s1 gets negative, so our answer will be s3 plus s3 minus s1. And max answer equals max of max answer and answer. The same goes for other two. So if any of the numbers is, if any of the bags contain only one number, then it makes sense to subtract only this number. Otherwise, at least every bag, if we haven't hit any of this, then every bag has at least two numbers. It makes sense to take like two smaller of M1, M2, and it will be our answer. Okay. So here we have like so everything gets this plus except we take a couple of things with minus and we subtract them twice because we already counted them with plus here. We want two smaller of M1 and M2, right? Or actually, wait, numbers are non-negative. Okay, numbers are non-negative because otherwise it would make sense to subtract negative numbers. Right, it's very good that numbers are non-negative. Otherwise, entire solution would be wrong. Yeah, initial numbers are negative, right? Here we want two smaller, and I suggest doing like so. So we take the sum and we subtract max of. I'm not sure whether it works or not, to be honest. It makes sense. It makes a lot of sense to me. Okay. Let's try. Okay, accumulates not found. Potentially accumulate is in numeric. 18 is not the optimal answer. Oh, because we have like one of the elements is of one set. Wait. Like, what was the optimal answer here? We said like we are going to subtract these two, which should be like here, no? But we only hit it when we have one of the sets equals size equal to 1. Why exactly? Like this scheme can be implemented regardless of how many numbers of which kind do we have. Yeah, so yes, correct. Like here we have two numbers from two different sets. It's minus with negative sign, right? And here we can say like, if we have only negative numbers in one set, then it means that it's entirely is negative. It's entirely negative. Because if it's not entirely negative, then like it won't be emptied. When a number of it's positive, then it's going to remain such. I'm also not sure that this can't overflow. So since minimum elements can easily overflow when there are 3 of them. Yeah, I don't know. It seems reasonable. Like here we only have, no, okay. Obviously not. Right. Or actually we can make it like in the same way. S1 plus S2 plus S3 minus 2 times so we want like 2 maximum, right? We can also output simply maximum of these two possibilities, right? I feel like we can just output this. So like in a first example, we only have negative numbers in one of the sets, and it makes sense to this set to have as a small sum as possible. In this example, in the second example, we have two negative numbers, one each in its own set. It makes sense to make this as minimum as possible. So here, this is with minus minus, so it's plus, therefore we maximize. Here, this is with minus, so we minimize. Yeah, makes a lot of sense to me. Let's try. I don't know. I don't think we have any overflow issues. And it's still in queue. Okay, let's wait because it's important. I'm not 100% confident in this much. So it makes sense to wait a bit. I bet all of my friends already solved like everything, but that's okay. It's unrated, so we are not in the high or anything else. So apparently we don't care about minus 50. Okay, it takes too long. Let's check the next problem. We will uncommand this when we need it. Okay, it's still in queue. Okay. There are n cells numbered from 1 to n, left to right, okay? I have two robots. We have to place robots over. Exactly k moves, okay. I suppose it makes left to right. And does not move out of the box, okay. Each cell has a value. The sequence of cells in a good path in the order. Okay. Okay, we just take the sum of all values that we visited. Oh, okay, so we want to compute the number of, so far it sounds like dp big O of nk. Yes, let's do just this. I think it's correct. Still in Q. I don't know. Wait, what is Q? What is that? Oh, okay, so it's more interesting than that. We have a couple of queries. Huh. Yeah, I don't think it matters. I don't think it matters because we can just maintain how many paths visit current cell of given length. No, the total number of visits to a given cell, right? And I think it's recomputed like very easily. Okay, let's wait until it runs. Okay. I think these queries do not make problem different. I guess we can leave it permanently in all our templates. But whatever. Oh, initial 0. Okay. Is it 0 though? I feel like it should be 1. Okay, okay. No, actually, the layers are in different order, right? So the p at ij equals a number of time aj in pass of length I plus 1, okay. And this value can be recomputed easily. And then we have to like just answer queries quickly. And we will also be able to do it because an answer is dp at k minus 1 j times aj right? And we can compute initial value, and then we just update values of aj. They change only one summand in the sum, and we can process it easily. Okay. And we have first level filled like this because, like, obviously, if you want to consider pass of length 1, then. Or wait, it's like that. Okay, I was not paying attention. We start at C0. Okay. Very stupid formulation, whatever. Because actual length of the path is k plus 1 in terms of cells. Or actually, it makes sense if you like path of length I means that you have I transitions. Okay, it makes sense. It makes a lot of sense. Okay, I suppose that we can. How many times are you going to get? No, it's not as simple. It's not as simple. My original intention was to was as follows, like if j, and it makes sense to add like so. It also makes sense to add like so. I believe that this dp is actually produces some sort of. No, it would. Yes, it does not produce what I would like to see. Because like why? Here is number of times j plus 1 is counted in paths of length I. And from j plus 1 and length I, we can go to j and length I plus 1. Right? But I think that we also need to add something like this. Not like this, but yeah, like this. Because like, even if we are not in the current cell, we are still interested in how many, like we were in the current cell and then we diverge to some sites, right? No, wait, I don't think it's what we want. I don't think this is what we want. Also, let me do it like this because, yeah, I think we're still missing something, but we're getting close, like with that observation. And here what I wanted to do is I want to add rather efficiently. I think this is efficient enough. There is something wrong. No, there is wrong. It is wrong. Okay, the index and value. Okay. I think this DP is incorrect, but some other DP is correct. So let's see how this performs, and then we'll be able to make some conclusions from here. Makes sense to use J. No, not like that, but like that. Here we can't do it much better, so we'll just do this. Just let has children. Okay. Yeah, because yes. Yeah, let me also call this I add because we add in place. It makes more sense. Oh, okay. Those queries, wait. Yeah, so queries maintain effects. Okay. What do we want to add? We want actually to add the pkj. Want to subtract this, then we want to set aj equals square second. Then we want to add it, but this should go with minus. Yeah, because this, I believe, can yield a negative result. I don't think it works in the way we implemented it currently. Excuse me. Oh, stop. I just wanted to change the extension. Okay, okay. What do you mean? What is wrong? 26, line 26, okay. Reasonable. 64. They say that this is incorrect. How is that incorrect? Oh, because J is undefined. Right. J should be queried first. You see, I'm pretty sure that answer can be represented in some coefficient times AJ, because this is how paths work. Okay, you're like paths, the structure of paths does not change because we change values. So this formula, general, should be correct, and it means that we can process squares in such manner. But I think that this current DP is incorrect, and if it does not work, then I will need to write down something on the paper. Don't have, okay, not great. We are trying to read into the pair explicitly. Let me create a specific instantiation. Yeah, this first. Will it work now? Why so? Yes, but I defined it explicitly. Do you want it like so? Not understand. Okay. Apparently, our template needs a bit of work. But it's okay. I mean, if we don't try to does not take one argument because I forgot this part. I forgot this part, but it's not necessary here. Okay, so it's not correct from the very start, which means that we did something wrong. Let's actually take a look, because I believe we'll be able to figure out very quickly what is wrong with our DP. Yeah, initial condition is correct, like 100%. Also, like here, also here length of pass is 1, and we say that answers are 3, 4, 4, 4, 3. Is it correct? Let me think. Initially, I have like everything is in this. How many ways to visit leftmost? Like so. We can start here. Can start here, then it's counted 4 times. Okay. How many ways to visit this? We can start here. No, we get 2. We can start here. And we get another 2. We can start very far away, and we get another 1. Yeah, you see, I can't introduce another param into our DP because it will become cubic, and it obviously does not fit into time limit, I believe. Or actually, but this is already huge, like memory. Yeah, quadratic memory is what's expected here, I believe. And so a lot of people already solved it. The correct answers are like 5 and 5. No, correct answers are 4, 5, 6, 5, 4. No, not even like so. We can also have like this visit and this visit. I don't understand. It's okay. Okay. Well, what if we like manually? No, yes. I don't know. These are too huge. Wait, so our coefficients, like these coefficients, are not correct? I don't understand. I'm pretty sure these are correct. Oh, that's 1, of course. What I was thinking. Have pass like this, and this makes only 2 of them. I was counting, yes, I was counting length 2 pass. But apparently, here we have 2 and 2 ways to visit these. Here we either start from here and we get 2, or get from here and we get 4. And in the center, the same thing happens. So correct coefficients are like so. And once we have correct coefficient, everything works. Okay. And here, correct coefficients were these numbers, I believe. Let's check it on the second case. Because here we have like 2 and I had length 2. But if these numbers were correct, or actually were they correct or they were not correct? Okay, this is one way, this is, here's 1, here is 2. Also have paths like this, which is another one. Also have paths like this, which that's another one, okay. Still too small. Okay, so coefficients 2, couple of 4s and 2 are correct for first layer. For second layer, we have some different coefficients. And I'm struggling to figure out what are these coefficients or why they are like this. Well, not always. Okay, so you don't have this path. This and here is 2, here is 2. Okay, but here it should be 9. Okay. And then potentially this is 10. Check if these coefficients are correct. Still missing something. Can't believe it. I'm missing around 10. Oh my, it's difficult. But this is the only thing that we visit. I don't understand. We can't have another DP param, so we have to figure out how to live with this too. Right. This can't happen all the time, I believe. This coefficient still should be incorrect, I believe. Yes, so second row coefficients are not correct. But first row is correct. Not a big success, I must say. So this value is counted 4 times, but we don't know in which pass, and that's terrible. Like, how are we expected to calculate? Many times this is in some pass. What if instead of having like this, we'll have 2dp? So first counts this, and second counts a number of paths ending in some location. No, it's still not enough. I don't understand. Still not enough. Like, but we can't have like 3 params in this dp. What is next problem about? We're given a tree. Each vertex has a value. We root the tree at some vertex. Okay. Distinctive root is found on all paths that start at V at end some other nodes. Values counter are distinct. Okay. Find the number of distinctive roots. Okay. Let me take a break in the recording and I'll come back. Honestly, I still don't understand how these coefficients are formed, but I'm almost 100% sure that we need these coefficients to compute at least anything. Because without coefficients, it's impossible to efficiently update values. This is what I think so far. But I figure out that this coefficient needs to be updated like so. Yeah, so these coefficients indeed have to be updated like so. This coefficient tell me nothing, I don't understand. Like here, for example, we have a pass of length 40. What I'm supposed to do for this? Also, the values that we compute here are incorrect. Because like not every pass have to be multiplied by 2. Okay, one way to solve it is to add another param. Okay, so it turns out I was very stupid about problem D, because what we really want to do is not necessarily compute like coefficient straight away. What we would like to do instead is use more or less the same dynamic programming to compute the number of paths that end in a given location J after given number of moves. This can obviously be computed like by 2 transitions, right? You can go from J minus 1 in length I to J and length I plus 1, and you can go from J plus 1 in length I to position J and length I plus 1. So the Pj is the number of paths of length I ending at position J. After that, we can compute coefficients of in our expression the following way. So our sum will be again sum of coefficient at position let me use the same index j times, so we will use this number of paths to compute the coefficients for j in range n. Okay. So coefficients j will contain the coefficient of aj in the sum. What we do is coefficient j is equal to sum dp ij times dp k minus ij for I in range k plus 1. So this is correct because it says the following, like how many paths of length I enter j, and this says how many paths of length k minus I enter j. And these paths you can imagine that these are not paths of length k minus I ending at j, but the same reverse the path, and imagine that these are the paths of length k minus I starting at j, and therefore we get how many paths in total pass through position j after I moves. And yeah, and therefore we get the following expression for coefficients, and then s is simply equal to that, and then you can answer queries, and as you can see, it got accepted. Yeah, so I was very stupid about that. I apologize. Very bad performance in terms of on the 3 problems solved. I don't know, 400 something rank. Well, at least we figured out how to solve this problem. Okay. I won't be doing problem E because now I'm very upset about myself and this problem. And yeah, very stupid of me not realizing that we can compute coefficients post factum after we compute number of paths. I was super disappointed. Hope you had better content than I did. And even if you did not, I mean, at least we learned something now. I remember this fact that you can count paths like this, because this approach is also present in Catalan numbers computation. If you compute them as paths that never go under the diagonal, then you can get pretty much the same formula style, the same style formula. Well, I hope I will remember it next time, and I hope you will remember the idea. So we first count paths, and we count passing through specific location at specific time as a product, then we can sum over time. So both of these parts are big O of nk, and therefore it works. And yeah. Thanks to Anton group, whose solution led me to this realization. It's, yeah, so let's try to turn this unfortunate sequence of events to our profit. So suppose you have not solved a problem on the content that you really wanted to solve. What do you do next? I was really upset. I just walked away from the contest, and it was a really poor decision. But then I did a good decision. I decided to look at the submissions of my friends. And because I have, most of my friends are rated higher than me, well, particularly because I add more people, even some of them I don't know in person, but I heard about them who are higher rated than me. And after the contest, I can open their submission, check what approach they used, and yeah, it really helps to improve. Of course, reading editorials helps, but also reading the submissions of your friends helps a lot. Because, I mean, if you don't understand something in their submission, you can ask them. The probability that they will respond to, I believe, is a bit higher than the probability that contest setter will respond to you personally in the huge discussion Codeforces, but they also respond sometimes. So yeah, I recommend having a lot of friends who are a bit higher rated than you, and whenever you don't solve the problems that you wanted to solve on the contest, go through their submission, use it to your advantage. For example, I won't forget this trick for a very long time. But yeah, yeah. So also let me check. Like this ran in how many? This was 530 milliseconds. Okay. Oh, yeah. Well, I said that we have like pragmas, and I said that they sometimes help, but I did not show it in action. Okay, so specifically here, they did not help, and potentially because we have like this operation. But I don't know. Potentially something different happened. And it was the reason that's why. Potentially we need to use a different compiler. Let's see what happens on 64-bit. Okay, on 64-bit, it runs faster, but it's not always the case. What about version without pragmas? Okay, so version without pragmas runs very fast on on 64-bit system. So potentially you can also use this to your advantage. So yeah, pragmas sometimes help, they don't help always. And this is the case for pretty much every hardware style optimization. Okay, so yeah, if you feel like pragmas can help in this specific case, don't hesitate to add them. Maybe it will help you. Again, a short resume. In a first problem, sample greedy solves it, but I've at first missed solve it because I did not realize that we can obtain prefix which starts like 989, so that we have to settle for 987, etc. It turns out if second digit is the first that you stop, that you can get 989012, and it's bigger. And it's bigger because its prefix of 3 digits is as maximal as possible. So yeah, problem A was greedy. Problem B, like we just brute forced through all reasonable values to change every element. So, and also at first I got wrong answer because I'm a fool and I did not initialize correctly. When you want to minimize something, then you initialize with max possible value. When you want to initialize with 0 when you want to maximize something. Problem C, again, you either need to have one set fully negative or one element from two elements, one from two different sets. with negative, everything else can be made positive. You want to make things positive because they all numbers are positive. So you want to subtract as little numbers as possible. So we just check, like this corresponds to having one full negative set. This corresponds to having two negative numbers in different sets. Problem D, count paths, count coefficients. Then you can update coefficients effectively. Update numbers, and your sum changes only in one coefficient. Problem E, I don't know, maybe like if I have time on the weekends, we'll go through all problems that I have not solved on contests of this week and probably upsolve some of them. Yeah, so I hope you had a good contest, and if you did not, then at least you, as I did, you learn from your mistakes, and next contest you will get positive rating change, right? So there's always something positive in every contest. You either get like better immediately, or you get better in the future, which is like also good, right? So I hope it was educational, despite me being a fool and not being able to figure several simple problems during the entire hour. See you on the weekends. We'll have at Coder contests. And when I was announcing things, on Monday, I had a video with like upcoming contests of this week. And I did not realize that Coder has two contests this week, one beginner on Sunday, one regular on Saturday. I'll try to attend both of them because they are both a suitable time for me. I did not realize that they have a beginner contest on Sunday because it was not announced at the moment that I was making my video. But if you're interested, definitely attend this one, it's good. And also Code Chef Long Challenge is still ongoing. I solved a couple more problems from there, still not on the first page, but I think I'll be there soon in the standings. So yeah, hope it helps. And what can I say? See you next time. Bye-bye.